And here we will talk about the same structure, which was G, and it was d alpha upon dx alpha, where alpha belongs to 0, 1, 2, 3. This was our set. Then our H was our H was 4x cube, 12x square, 24x, 24 and 0, and with two operation star, and the star was G cross G to a G, right? And the rule was this star going to take two element from the set, let's say d alpha upon dx alpha and d beta and dx beta, and it is going to produce d alpha dx alpha star d beta dx beta. And what it's gonna do is that it's gonna take absolute value of alpha minus beta and absolute value of alpha minus beta, right? And then we have another rule which was for O, and this is gonna take H cross H, and this is going to and what does it does, it's going to take one element, like let's say d alpha by dx alpha from G, and one element from H, let's say a polynomial, let's say x power n, because all is in the form of x power n. And what it is gonna do, that it is gonna take the d alpha dx alpha and operate with x power n. So it will be usual meaning of operation x power n, right? And it is going to produce a d alpha by dx alpha of x power n, and then its nth derivative, and that will be just nth derivative of x power n. And so this kind of forms, this has closure, it has associativity, and the associativity only works if, remember this, if AB coming from G and C coming from H, then only associativity is going to work. And closure is same, that closure with respect to this associativity is respect to star, this closure is with respect to, we defined AB coming from G, then AOB, AB, A coming from G, B coming from H, so AOB must belongs to H. So this is closure, by this we mean. And for here, AB coming from G, C coming from H, and with respect to star, it's associativity, right? We had identity, and we defined identity that E dot A equal to A. Now we said this E must come from G and A must come from H. A must come from H, and this is how we define identity, right? And there is no, we can say there is no commutativity in this. And the region, now what is commutative, then we have to check for this. What does commutativity means for this kind of operation? We said O is G cross H to H. Well, then G could be d alpha by dx alpha, and H could be ax power n. Now this has no meaning with usual definition of whatever this operator is. So there is no associativity with respect to this. What about commutativity? There is no commutativity with respect to this operation. What about commutativity with respect to a star? Well, d alpha upon dx alpha with a star and d beta upon dx beta is equal to d alpha minus beta upon dx alpha minus beta. We know from the definition of a star. Now what if we swap this? Then we get d beta upon dx alpha operated with d beta upon dx beta. Then we get d, this is alpha, then we get d beta minus alpha upon d beta minus alpha. Are they equal? Well, it is, because alpha minus beta absolute value is equal to beta minus alpha absolute value. So it is commutative, right? So it is commutative with respect to this structure, right? so it is also commutative. So we have this kind of rule. So our set now see this. So we have two set GH and two operation star and O, right? So what happens to GO? Well, since O is defined G cross H to H, this GO satisfies closure. It satisfies, does it satisfy associativity? Well, it does. We can check it. What is associativity? Associativity is dy dx alpha, A, B come from G and C come from H. So A coming from and B also coming from, and this with C, ax power n. Now is this equal to d alpha dx alpha of d beta dx beta operated with axn? Well, it is, because this is defined, right, and this is also defined, correct? So if this is defined and this is defined, but then we have a problem here. What does associativity means? What does this means? This is defined, but then this is not defined, right? Because this operation is only true for G cross H to H. So this is not defined, right? So there is no associativity in this. But then we said there could be associativity. Well, that was only with respect to this star and d beta by dx beta with star ax power n. But then here is a problem. What does this star means? Well, star should take, we said star is operation defined from G cross G to H, but then here it is not defined, right? So how does it solve this now? The problem is now different. Neither this is defined, neither this is defined, right? So how do we do it? Well, there is a way to do it, and the associativity will be like this. D alpha upon dx alpha, since alpha beta alpha A and B elements should come from G and C from H. Here should be a star, not a star, it should be O. Okay, so dO and d beta by dx beta, and here it cannot be O because O is defined from it can be O, yes, it can be O, and then H, not H, ax power n. So this is legitimate, we can do this, but then for associativity, this condition must be equal to this condition, and this is not defined because O is defined from G cross H to G, right? G cross G to H, and this is G cross G, but G cross G is defined only for a star, G cross G. So this must be a star. So if it is a star, then what happens is this must be a star, but if this is a star, then this is not defined, right? So there is no associativity, so we cannot do associativity, right? So there is no way to do associativity here. So what we did was wrong. Even after this assumption, we cannot do associativity. So there is no way to do this. There is no associativity in this. It fails. Even after this composition rule, even after we extend our set and added another operation, it still failed to be associativity. All right. Now the only way to define associativity now is with respect to, if we define, if only with respect to star. This can be done for associativity, right? Now because then what is a star? A star will take G cross G to H. Now we choose any element from this. Let's say alpha, which is, I am writing alpha, but it is order of derivative alpha. Let's say 3 element we choose, alpha, beta, gamma. Then what is associativity? It will take 3 element alpha, beta, gamma, right? And this star will produce for associativity. For associativity, it is going to do these 2 things, right? So this star is G cross G to G, right? So it is going to take derivative d alpha dx alpha, d beta dx beta, d gamma dx gamma. Now for associativity, what does it mean? Well, it means d alpha dx alpha with star and d beta dx beta star d gamma dx gamma, and this must be equal to d alpha dx alpha with star d beta dx beta, and this is going to star with d gamma dx gamma. Now evaluate this. Well, we know d alpha dx alpha, and by the rule of star it says the answer is beta minus gamma absolute value, and this is again beta minus gamma absolute value. What will be for this? Well, again absolute value rule, so it will be d alpha minus this and its absolute value, and then here again alpha minus absolute value, right? Now is this equal to, after composing here we will see are they equal. This and this is alpha minus beta absolute value, and this is again alpha minus beta absolute value with gamma. Well, check it. This and this composition is, these are absolute value. So this will be alpha minus beta minus gamma absolute value by dx, again alpha minus beta absolute value minus gamma absolute value, right? Now are these and these equal? That's what we have to check. Is absolute value of alpha minus beta minus gamma is equal to absolute value of alpha minus beta minus gamma? This is what we have to check. Now to check this, let's take an example. We know alpha, beta, gamma must belongs to 0, 1, 2, 3, right? We have defined this. Now let's say alpha equal 1, beta equal 2, gamma equal 3. Now let's substitute its value into this. So we get, first we have to calculate beta minus gamma. So beta minus gamma is equal to, beta is, what is our beta? So beta is 2, gamma is 3. So 2 minus 3 is minus 1, answer is 1. Now we have to do alpha minus this whole, which we have already calculated 1, and alpha is 1. So 1 minus, so we get, what do we get is absolute value of alpha, which is 1, minus the value of this we have calculated, which is 1. The answer is absolute value of 0 is 0. So for this we got 0. Now how about this one? Well, let's do it. First we have to do alpha minus beta. So let's do alpha minus beta. Alpha is 1, beta is 2, so it will be minus 1, answer is 1. So you have to substitute 1 here, so we get 1, absolute value of 1 minus gamma is 3, 1 minus 3 is minus 2, we got 2. So for this we got 2, and for this we got here 0. So they are not equal. It means they do not even follow associativity with respect to this composition, right? There is no associativity in this. It means no matter how we add this structure, it is failing for this kind of set. So we have only GH and operation O. with usual meaning G cross H to H. O is star, we do not take it right now because we tried so many way and it is still failed. Maybe we can construct maybe with another definition of star and all kind of things, but that is construction. We can do it, but we have to check carefully and we have to do a lot of work, right? So we started with this structure and then we got G with 2 operation, and then we said why 2? We can extend to star 1, star 2, star 3 and so on. We can define it, right? 2 operation, we can do this. But then said this was one path. The another path could be, we said, take 2 set and an operation, right? But why stop here? Well, let's extend this also. 3 set G, H, J and an operation, right? And we can do this, right? And this will be, maybe we can extend this G1, G2, G3 dot 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 and with an operation, right? And these all can these all are a structure, but different structure. These are going different structure, these are going different structure. Now what we do here, we can compose. Now from here what we can do, here are one set with many operation, here are many set with one operation. Now we can put together those idea and then we says why not this kind of things. Let's say G1, G2 dot 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 Gn number of set, and then we have also operation star 1, star 2, star 3 dot 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 star n. Many number of set, many number of operation, and this is also an structure, right? These are also an structure. We define this, right? So these are different kind of structure, but they all, see, in all of them there is a set, right? So even smaller than this is also coming from simply a set G, right? But not only this set, this structure is coming from G with belongs to. Now this is a very different kind of idea I am talking about. Even if you go back, there is a different structure sitting there. That is itself set theory. Okay, and from there we are creating all the structure we are building, right? So these are all different kind of algebraic structure. In this direction it's completely different. It is action. These are the action going on. These are the you can say operation. These are operation going on here. In this side operation, in this side action. So and here they are both. We can combine operation plus action together, right? So this is a different idea. This is operation going on, here is action going on, and we combine them and we get operation plus action. But all of them is coming from set theory, and we will talk about this kind of structure, right? So now we will stop here.